Okay, Assalamualaikum and good morning everyone. So today we are going to continue with the second part of our lecture on surface integral. That is the surface integral for the vector value function. So yesterday we have taken a look into surface integral for the vector function. So today we will continue with surface integral for the vector value function. Okay, so semalam kita dah tengok the surface integral for the vector value function where we have taken a look at cases that if the projection of the vector, the scalar function is either on xy plane or yz plane, because we have three-dimension plane, you have x, y and z, hence the projection can be in either one of these three planes. Okay, so the associate formula will be changed as well if the projected is on xy plane. So z will be the function of x and y. So we will substitute in the equation of G here that z terms will be in term of xy. So your overall will be dx, dy or dy, dx with respect to that two variables. Okay, so another one we have the surface integral. The projection is on xz plane. So y will be the one in the term of xz. So xz plane yang tak ada. So kita ubah y dalam bentuk dalam equation of y and x and z. Okay. So the associate formula will also be different, and then you are going to have the integration will be with respect to dx, dz or dz, dx. Okay. So and then we have another one, the surface integral if the projection is on yz plane. So from here, the function will be x equal to function of y and z, and then from there, the what we call it, the associate derivative will be on dy dz. Okay, so we have taken a look into this example and this example as well, and then we are going to we have see this example as well, and this example you can try by yourself. That is the jawapan akhir 14.8492 pi. Or in this case, you have to change the integration into polar coordinates because you have the associate, what we call it, solid is in term of cone. So we have one in term of circle. So it will be easy for you to do the integration with respect to polar coordinates theta. Okay. So today we will continue with the surface integral involving the vector value function. If you function f where you have the function of x, y and z for the item, and you have the function of g, x, y and z for the j term, and then you have the function of h of x, y and z for the j term. Okay, so all of this has continuous components on the oriented surface. Okay, oriented surface S, and if vector n is the unit normal vector of the orientation at x, y and z, then the integration of the vector function, okay, over the region R, it will be equal to taking the integration of vector f with respect having the dot product with the unit normal vector, okay, with respect to ds. So this is integral of vector f over the surface S, or it is also known as the surface integral of f. So dia ada dua nama, surface integral of f over S, atau also called the flux integral. Sometimes the question just tell you find the flux integral for the vector f, for example. Okay, over S, or the surface integral of the normal component of f over S. So these three are the possible, not the possible, are the associate integration over the bounded region R for vector f and the unit normal vector n. Okay. So from here, to compute the unit normal vector, because we have the term of unit normal vector here. vector n. Okay. So from here, to compute the unit normal to a surface as given by equation z equal to function of xy, first we will rewrite the equation as z minus zxy. So develop this equation. Okay. Z equal to z minus xy. It will be equal to 0. Okay. Where the level surface for the function g, x, y and z equal to z minus zxy. So this is the level surface of the function. So from here, you will have the gradient delta g equal to negative delta z over delta xi minus delta z over delta yj plus k. Okay. Where delta g equal to taking the partial derivative of this one. Okay. Taking the partial derivative of I component, that is this one. I component is yang ini, function of f. Okay. J component is function of g and k component is function of z. That is why you are going to have the equation will become this one. Okay. Partial derivative with respect to x, y and z for each I, j and k term. Multiply with z minus zy. Okay. So the notation, the vector differential operation delta will be equal to this one. Okay. Given by this one, delta over delta xi plus delta over delta yj plus delta over delta z. Okay. Okay. And this is the gradient. How to get the gradient? So the unit normal vector to S, that is n, at the point of x, y and z, it is given by unit normal vector n equal to taking the gradient g divide by the Euclidean length of the gradient g. So Euclidean length ni macam yang kita tengok dalam unit normal vector atau dalam vector yang awak belajar vector value function dalam engineering mathematics 1 as well. So later on we will recap. Okay. So delta g, the Euclidean length equal to taking the square root of delta z over delta x squared plus delta z over delta y squared plus 1. Okay. And the delta g, okay, to get the unit normal vector equal to negative of delta z over delta xi minus delta z over delta yj plus k. So this is how you will get the unit normal vector. Substitute both in this equation, then we will get the unit normal vector. Okay. So the next one, because we are dealing with the vector function, so you will have the direction as well, whether it is point upward, downward, and the associate, whether you are going to have the positive k component, the negative k components, and so on. So if the unit normal vector is pointed upwards, then in this case, you are going to have the positive k components. Okay. If the unit normal vector or the solid is facing downward the unit normal vector, then you are going to have the negative k component. If the unit normal vector will have the right unit normal, then in this case you are going to have the positive j component. It will be facing on the right side. Okay. So this is the terminology, and continuation from this one, if you are going to have either the unit normal vector is left unit, forward, or backward. Okay. So the left unit normal, if the j component will have the negative value, so meaning that the solid will facing on the left of the will have the left unit normal vector. Okay. If you are going to have the positive I component, then the unit normal vector will have the forward unit normal vector. And if you have negative I component, then you are going to have the backward unit normal. Okay. And from here, how we are going to define the surface integral involving the vector value function. Okay. So let's take a look at this one. For the surface integral that involving the vector value function, suppose that you have S is the portion of the surface. We have Z equal to 1 minus X squared minus Y squared. So this is an example. Okay. So it is located above the xy plane. The surface is located at above the xy plane, meaning that the z function of 1 minus x squared minus y squared, it is located at the above of xy plane. And let S be oriented by upward unit. Let S be oriented by upward normals, and let vector f function of x, y, and z is given by xi plus yj plus zk. So evaluate the surface integral for vector f multiply with vector n and the integration with respect to the surface over the bounded region of R. Okay. So kalau awak tengok dia punya equation, z sama dengan 1 minus x squared minus y squared, which is equal to z equal to 1 minus x squared plus y squared. So kalau kita tengok balik equation ni, boleh juga kita cakapkan ianya adalah satu hemisfera. Okay. So dekat belah atas. So it is pointed above the xy plane. So xy plane awak adalah this one. Dekat bawah ni xy plane. Okay. So dia terletak dekat above. So this is the notation for this one. So from here, it is located above the xy plane, and then you were also given let S be oriented by upward unit normals, and let F be the vector function of xi plus yj plus zk. So if we do dia punya graphical picture of this surface, so z equal to 1 minus x squared minus y squared. So you will have, it will be something like this. And dia punya tapak dekat bawah tu, this one, when z equal to 0. Okay. So bila z sama dengan kosong, when z equal to 0, so you akan dapat gantikan this one, kosong, akan sama dengan 1 minus x squared minus y squared. So pindah belah kanan, it will become x squared plus y squared equal to 1. That is why you dapat dia punya region adalah bulatan dekat bawah. That one. So boleh tengok dulu sebelum kita tengok solution dia. I want to change to my iPad. Okay, so from here we have this figure just now. Okay, so how we are going to solve this one? So because you have z equal to 1 minus x squared minus y squared, so we will have, and this is your vector f. So given this is your vector f, and then we have to dapatkan the unit normal vector n. Okay, so this one, dia punya tapak region R, this is from the equation of z equal to 1 minus x squared minus y squared. So bila z equal to kosong. Why z equal to 0? Because the region is located at the xy plane. So 1 minus x squared minus y squared equal to 0, meaning that you have x squared plus y squared equal to 1. So it is a circle. If we draw the xy plane, so you are going to have a circle here, negative 1 and 1, as the bounded region of R. So kalau circle nanti kita nak buat integration dia, it will be easy kalau kita guna polar coordinates. Okay. So this is the region R, the tapak. So you can draw that one first before we take a look in how to solve this surface integral. Okay, kita nak dapatkan the unit normal vector of this vector function. Okay. Done with this one. Ui, dah belum? Belum. Okay. Tak ramai kelas pagi ni. Ramai join yang petang. 32 orang je. So, untuk dapatkan the unit normal vector, it will be equal to taking dia punya, apa nama dia? Unit normal vector. Okay. So, kita nak dapatkan dia punya unit normal vector. So, from here, the unit normal vector n, it will be equal to delta G over the Euclidean length of delta G. So later on the Euclidean length ni boleh kita hapuskan. Okay. And then you were given, okay, Z equal to 1 minus X squared minus Y squared. So from here, G of X, Y, Z, yang ini dia bagi Z minus Z of X, Y. Okay, so it will be equal to taking Z tolak Z, X, Y is this equation. Okay, Z minus 1 minus X squared minus Y squared. Z minus 1 plus X squared plus Y squared. Okay, so it will be also Z plus X squared plus Y squared minus 1. Okay, and then nak dapatkan delta of G. This is equal to partial derivative of I component plus partial derivative over J component plus partial derivative of K component. Okay, having the dot product with Z minus Z X Y. Okay, so meaning that you have to find partial derivative of I plus partial derivative of J plus partial derivative of K of Z plus X squared plus Y squared minus 1. Meaning that dot product. So darabkan dah setiap satu. So delta over delta X, Z plus X squared plus Y squared minus 1, I plus delta over delta Y, Z plus X squared plus Y squared minus 1, J plus delta over delta Z, Z plus X squared plus Y squared minus 1, K. Okay. So, bezakan this one terhadap X. So, tengok X term, Y tengok Y term, and Z tengok Z term only. For this one, you are going to have 2 XI plus 2 YJ plus K. Okay. So this is the delta G. And then nak dapatkan Euclidean length of delta G. So boleh salin dulu, yang nak salin yang ni. So Euclidean length of delta G equal to delta Z over delta X squared plus delta Z over delta Y squared plus 1. Square root of 2X kuasa 2 tambah 2Y kuasa 2 tambah 1. Square root of 4X squared tambah 4Y squared tambah 1. Salah. Okay. So the unit normal vector n akan sama dengan delta G over Euclidean length of delta G. 2xi plus 2yj plus k over set 4x squared 4y squared tambah 1. So the surface integral integration over the surface f dot n ds equal to integration over the bounded region R f dot n set of delta z over delta x squared plus delta z over delta y squared plus 1 dA. So we are going to calculate the this one. Okay, done. So calculating the surface integral, it will be equal to integration over the bounded region R f dot n is vector f dikalikan the unit normal vector n tadi kita ada 2xi tambah 2yj tambah dengan k over set 4x squared tambah 4y squared tambah 1 dikalikan dengan delta z over delta x kita dapat 2x dan delta z over delta x yang ini tak ada negatif. This is no negative. It's a positive 2x and 2y. Okay. So set bagi 2x squared plus 2y squared plus 1. Okay. This one. Okay. D So how we are going to find DA? Kita keluar. Okay. So how we are going to find DA based on the region. So DA based on the region that we have calculated earlier. This is your X and this is your Y. You have -1 and 1 over here. So bounded region R. Okay. So it will be easy using polar coordinate of R and theta. Okay. So cuba buat apakah dia punya boundary for R dan apakah dia punya boundary untuk theta. Okay. The integration over region R will be easy using polar coordinates. So determine what is your R and what is your theta. Okay, R dari berapa ke berapa? Theta dari berapa ke berapa? So anyone dapat?
R kosong. ke 1.
Betul. Ramona. Tita.
Kosong ke 2 pi.
Yap, betul. Okay. Sebab dia satu bulatan full berjejari satu. So R from 0 to 1 and theta daripada 0 to 2 pi. So masukkanlah dalam the integration for that one. So the surface integral, okay, hence the surface integral integration daripada 0 ke 2 pi integration ke 1 2x squared tambah 2y squared tambah z K darab KI1 tambah z. Okay. Tambah z. Okay. Plus z dr d theta. R dr d theta. Okay. Tambah z darab dengan R dr d theta. Okay. Z adalah sama dengan 1 tolak x squared tolak y squared. Okay. So, given z equal to 1 minus x squared minus y squared. So, masukkan dekat dalam that equation, it will be integration 0 to 2 pi, 0 to 1, 2x squared tambah 2y squared tambah 1 tolak x squared tolak y squared. R dr d theta. So, it will be equal to integration 0 to 2 pi, 0 to 1, 2x squared tolak x squared. Jadi, x squared plus y squared plus 1 r dr d theta. So x squared tambah y squared akan sama dengan r squared. Okay. Change to polar coordinate, x squared plus y squared equal to r squared. So integration 0 to 2 pi, 0 to 1, r squared plus 1 multiply with r dr d theta. Integration 0 to pi, r cube plus r dr d theta. R kuasa 4 plus r kuasa 2 per 2 d theta. So 1/4 integration 0 to 2 pi 3/4 d theta equal to 3/4 theta. So sama dengan 3 pi per 2. Okay, that is the hasil of the integration. Nampak So ini satu contoh of the surface integral. Nanti kita tengok lagi satu example. How to evaluate the surface integral for the vector value function. 19. Ada soalan tak? Eh.
Miss,
Ha.
nak tanya.
Ha.
Yang Miss potong yang 2x squared dengan yang 4x squared tu, macam mana boleh pergi mana yang 4x squared tambah 4y squared tambah 1 tu?
Sebab yang ini 2x squared ni kalau kita kembangkan, okey, yang ini set delta z yang saya bulatkan ni. So delta z, set delta z adalah square root bagi 2x squared tambah 2x. Okey. 2 dia salah tulis ni. Square root bagi 2x di kuasa 2. Okey, ni this is 2x kuasa 2, 2y di kuasa 2. Tambah 2y kuasa 2 tambah 1. So saya ada salah tulis ni. So betul kan? Thank you Ramona. So dia ni akan jadi 4x squared tambah 4y squared tambah 1. So sama dengan yang bawah yang saya bulatkan ni. That is why kita boleh potong. Sebab dia sama. Okey. Dia 2x squared. This is actually salah tulis tadi. 2x kuasa 2 tambah 2y kuasa 2 tambah 1. Sebab partial derivative bagi z terhadap x, partial derivative z terhadap y. Kita dapat tadi partial derivative dia 2x dan juga 2y. So that is why kita boleh potongkan. Dapat semua? Dan ada soalan? Ada soalan? Firas okey? Nur Adeline? Fahim? Farhad tak ada dalam ni? Hafiz Fikri? Okay semua? Senyap je. Ada orang ke tak tu? Oi Dan. Dah semua. Senyap je duduk dah.
Dah, Doktor.
Dah, okay. So the next one, kita take a look into another example. Okay. So we have this example. Okay, if the surface S is given by an equation in the form of y, where z has continuous first partial derivative, and if r is in the projection of the surface on the xy plane, then the integration over the surface integral for the vector function f with respect to the unit normal vector n, it will be equal to taking the integration over the vector f minus delta z over delta xi minus delta z over delta yj plus k dA if S is oriented by upward normals. Okay, and if the surface integral for vector f multiply with the unit normal vector, okay, the flux integral of vector f, it will be equal to integration over the bounded region R vector f multiply with delta z over delta xi plus delta z over delta yj, that is the partial derivative with respect to I and j, minus k. Given that the integration is over dx dy if S is oriented by downward unit normal vector. Okay, so the difference is if it is oriented upward unit normal, you are going to have the positive k. So macam tadi, kalau dia upward kan, you are going to have the positive k unit normal vector. Okay, and then if it is oriented downward, if the surface is like this and then it is oriented downwards, then you are going to have the negative of k component. So in this case, we will take a look into this example. Okay, let S be the spera of x squared plus y squared plus z squared equal to a squared, and it is oriented by outward unit normal, outward keluar. Okay, and let f is a vector function that is equal to zk. So evaluate the flux integral for the unit normal vector f. Okay, so dia kata S be the spera of x squared plus y squared plus z squared equal to a squared. So this is the spera. Okay, satu spera yang mana dia punya jejari adalah a squared and it is oriented by outwards. So keluar unit normal vector. So kalau awak tengok ni, kita boleh bahagikan kepada dua. Okay. So yang belah atas, if you take a look into this one, we can divide this one to two side of the unit normal vector. Okay. So if bahagikan dua, yang belah atas dia akan pointed upward, yang belah bawah dia akan pointed downward. So this one akan jadi positive k and this one akan jadi negative k. Okay. So kita akan bahagikan dia kepada dua bahagian, bahagian satu dan juga bahagian dua, untuk dapatkan dia punya flux integral for this unit normal vector. So dia adalah satu spera, x squared plus y squared plus z squared equal to a squared. So macam mana kita nak dapatkan dia punya integration for this vector function? Kita akan gunakan formula sebelum ni, the first slide sebelum ni. So you are going to have integration over the bounded region S f dot n ds, it will be equal to integration over the bounded region R f dot negative delta z over delta x I minus delta z over delta y j plus K dA. Okay. And then ini untuk yang bahagian 1. Okay. Plus bahagian yang kedua akan sama dengan integration over the bounded region R, vector F didarab dengan delta Z over delta X I plus delta Z over delta Y J minus K dA. Okay. So this is the first and this is the second. We will make use of these two formula. Kita bahagikan dia kepada belah atas and also the belah bawah. Dan so kita bahagikan dua. Dia punya explanation is this one. Okay. So on the upper hemisphere, the outward unit normal vector is upward, while the lower hemisphere is downward. Okay. So since the different formula for these normals apply on the two hemisphere of the surface integral, so you are going to have S1 plus S2. So yang ini adalah surface 1. Okay. And then this is the surface 2. Sekejap So yang ini adalah surface 1. So this is the surface 1. Okay, and this is the surface 2. So surface 1 dia akan jadi satu hemisfera dekat belah atas. Okay. This is surface 1, X, Y and Z. And then surface 2 dia akan jadi dekat belah bawah punya. Okay. So like this. So X, Y and Z. So this is surface 1 and this is surface 2. Okay. So from here, kita akan gunakan dua of this formula. Okay. So this is the explanation for this one. So you are going to have integration over the surface. It will be equal to the summation for surface 1 and also the summation for surface 2. Okay. Yang ni tengah salin ke? This one. Are you copy this slide? So let's take a look into the upper surface first. So Z sama dengan Fxy. And then you are given this equation of x squared plus y squared plus z squared equal to 1. Okay. So you were given the equation of x squared plus y squared plus z squared equal to a squared. Okay. So daripada this one kita ada z equal to function of xy. So develop the equation for this one. Done with this slide. Or not yet? Done or not yet?
Done, Doctor.
Done. Okay. Okay, let's take a look into the projection on the xy plane. The sphere x squared plus y squared plus z squared equal to a squared. Okay, and then we have z equal to function of xy. Okay, so projection on the xy plane. So from here, x squared plus y squared plus z squared equal to a squared. So z akan sama dengan plus minus cert a squared minus x squared minus y squared. So the upper hemisphere it will become z equal to cert a squared minus x squared minus y squared. Okay. The lower hemisphere it will become z equal to negative cert of a squared minus x squared minus y squared. Okay. And you were given g function of x, y, z. Kita nak dapatkan dia punya unit normal vector equal to z minus z of xy. So it will become for upper hemisphere, this is your S1 and this is your S2. Okay, for upper hemisphere, that is S1. Okay. G of x, y, z akan sama dengan z minus z function of xy. Z minus cert a squared minus x squared minus y squared. Okay. So yang ini untuk kita dapatkan unit normal vector. Okay. So delta G akan sama dengan delta over delta xi plus delta over delta y j plus delta over delta z k. Multiply having the dot product with z minus cert a squared minus x squared minus y squared. Okay. So dapatkanlah dia punya this one, the partial derivative. So bezakan all of this one terhadap I, J dan juga K. Setiap of this one. Okay. Yang ini terhadap X, this one terhadap, bezakan terhadap Y juga, and this one terhadap Z juga. Okay. Dotkan. Partial derivative and then dotkan dia punya the dot product. So akan dapat negatif 1/2 A squared minus X squared minus Y squared kuasa negatif 1/2. Sebab 1/2 tolak 1 is negatif 1/2. Minus 2x. This is for I component. Okay. Plus negatif 1/2 A squared minus X squared minus Y squared. Negatif 2y for the J component plus K. Okay. So from here kita akan dapat dia punya delta G. So simplify this equation. 1/2, this one boleh hapuskan. 1/2, yang ini pun boleh hapuskan. So delta G, kalau awak simplify akan dapat delta G akan sama dengan X over cert of A squared minus X squared minus Y squared. X over cert A squared minus X squared minus Y squared I plus Y over cert A squared minus X squared minus Y squared J plus K. Aduh, hai. Plus K. Okay. So from here, the Euclidean length, yang ini saya simplify, the Euclidean length of delta G akan sama dengan square root bagi X squared plus Y squared over A squared. Dah kenapa pula tak boleh ni. So the Euclidean length for this unit normal vector, that is delta G akan sama dengan square root bagi X squared plus Y squared over A squared minus Y squared tambah 1. Okay. Ditambahkan dengan 1. So tambah 1, yang ini bawa pindah naik atas. Okay, darab silang. So if you settle this one, akan dapat square root A squared over A squared minus X squared minus. Okay. So the flux or the surface integral of F dot N ds akan sama dengan integration over the bounded region R zk multiply with vector N ds. Okay. So it will be equal to integration over the bounded region R zk having the dot product with the unit normal vector. So yang dia punya Euclidean length ni boleh dihapuskan. Okay. Terhapus macam example tadi. Macam example before this one. So saya terus salin dia punya this one as the unit normal vector. So masukkan yang ini dekat dalam this equation. So it will be dot having the dot product with X over cert A squared minus X squared minus Y squared I tambah Y over cert A squared minus X squared minus Y squared J. Okay. Plus K. Oh, ni tertinggal. Plus K. Okay. D E. So darabkan dah. So darabkan. Kita cuma darabkan yang K sahaja. Sebabnya I darab K akan jadi kosong. J darab K akan jadi kosong. So it will be integration over the bounded region R Z D E. So Z awak adalah sama dengan X squared square root bagi A squared minus X squared minus Y squared dA. So dA it will become over the X and Y region akan dapat dia punya this one, negative of A and A. So this is the bounded region of R. Okay, so from here kita change kepada polar coordinate with R and also theta. So it will be integrate daripada 0 ke 2 pi, 0 ke R, square root bagi A squared tolak X squared plus Y squared. R dr d theta. Okay, so settle for this one akan dapat sama dengan integrate 0 ke 2 pi 0 ke R sed A squared tolak R squared multiply with R dr d theta. Okay, so cuba settlekan that integration. Akan guna substitution. Settle up that integration, you are going to make use of integration by substitution. Okay, cuba settlekan yang ini. Okay. Cuba settlekan the integration. Kalau dah sudah, slide this one beritahu. Dan, ada yang dapat tak? Apa jawapan? Ada soalan? Ada yang dapat tak? Dan lah yang ni. Ramona dapat? Firas, Adeline, anyone get the answer for this one? Megat, Zafran, Lionel, Divya. Ramai je ni dalam ni. Winston, Lizong. Anyone get the answer for this one? Done or not yet with this slide? Hui, dah ke belum? Senyap juga dah ni. Fahim Dam? Shu'aib? Can you hear me guys? Are you done with this slide?
Dan.
Done. Okay. So, kita nak settlekan dia punya integration. Okay. We want to settle this integration on the upper part of the integration. Okay. So, for this one, saya nak settlekan this integration. Okay. So, the flux integral hence equal to integration 0 sampai 2 pi 0 sampai A R darat sed A squared tolak R squared. Okay. dr d theta. Okay. So using substitution, A akan sama dengan taking U sama dengan okay, taking U sama dengan A squared minus R squared. Okay. du over dr negatif 2R. Okay. So, du per negatif 2 dapat R dr. So, you get this term R dr. So, from here, it will be equal to 0 sampai 2 pi, 0 sampai A, U kuasa 1/2 du per negatif 2 d theta sama dengan negatif 1/2 0 sampai 2 pi u 1/2 tambah ni dia akan jadi u 3/2 kuasa 3/2 0 sampai a d theta. Okay. So, negatif 1/2 darab 2/3 0 sampai 2 pi U sama dengan A squared minus R squared kuasa 3/2 0 sampai A d theta. So, gantikan R squared dengan A squared. So, 0 tolak 0 akan dapat sama dengan kosong. Dan A squared tolak kosong akan dapat 1. So ni gantikan dalam ni, 0 pun kena gantikan dalam that one. So akan dapat negatif 1/3 0 sampai 2 pi negatif 0 tolak negatif A squared di theta. So dapat 1/3 A kuasa 3. This one jadi A kuasa 3. Okay. 1/3 A kuasa 3 theta. 0 sampai 2 pi. So dapatlah jawapan dia. 2/3 pi A kuasa 3. Okay. So this is the solution for S1 for upper hemisphere. Okay. So for S2, that is the lower hemisphere. So tadi kita dah dapat yang ini jadi simple sikit because we have find the unit normal vector. A squared minus x squared minus y squared. So delta G akan sama dengan negatif x over sert A squared minus x squared minus y squared I minus y over minus x squared minus y squared k j plus k. Okay. Ni tadi kita dah cari daripada soalan sebelum ni. So for negative orientation, this one you are going to have the surface or the flux of Fn ds akan sama dengan integration over the bounded region R f dot negative of the vector function dA. So it will be integration over the bounded region R z of k having the dot product negative of negative x over sert A squared minus x squared minus y squared I minus y over x squared minus y squared j plus k dA. Okay. So samalah tadi. Kita hanya dot product, dotkan yang k dengan k sahaja. Sebab yang ini jadi terhapus. So it will be integration over the bounded region R negative of, sebab ada negatif dekat luar ni. Okay. Negative of here. That's why it become negative over here. Negative z dA. So integration over the bounded region R negative of negative z is negative sert A squared tolak x squared tolak y squared dA. Okay. Change to polar coordinates. Sebab dia sama je. Cuma this time around dia adalah xy belah bawah. Okay. On the lower side. So this one. That is why we are going to make use of R and also theta. So change to polar coordinates, it will be the same as the upper part. So akan dapat integration 0 sampai 2 pi, 0 sampai A, sert of A squared tolak R squared dA. So kita dah buat, darabkan dengan R, dr d theta. Okay. So kita dah buat tadi, dapat sama dengan 2 pi A cube 2/3. It will be equal to 2/3 pi A kuasa 3. Ni adalah solution for S2. That is for lower hemisphere. So the flux integral akan sama dengan tambahkan kedua-duanya. Done. Okay, so kita dah dapat solution for S1 dan also solution for the lower part and also the upper part. So kita akan tambahkan sahaja untuk dapatkan the flux integral of the sphere. Okay. So nanti kita akan tengok in the next class, gunakan Stokes theorem, awak tak payah kira panjang-panjang macam ni. Dia jadi simple sahaja. Okay. So we will take a look into that one in Stokes theorems. So for this one, assignment sempat ke siap 10 hari bulan ni? Ke nak extend masa lagi?
Bagi saya kena extend tu, madam.
Saya setuju.
Cepat aja semua jawab. Okey lah. Exam start bila? Exam awak? 24
24.
Saya extend sampai 19 lah. Okay, nanti saya ni. Saya extend sampai 19 apa nama dia? 19 Januari ni. Februari. Januari. Okey, Februari kan tak sempat pula nak maki. Okey.
Terima kasih, madam.
Aku tak pernah dengar suara kau sebelum ni. Tiba-tiba bila cakap nak extend, Sedap suaranya. Handsome ke tak ni? Siapa tadi yang jawab? Muhammad apa? Arash. Oh ya ke? Inilah Arash. Saya tengok cerita Turki, ada orang tu nama Arash. Sama macam nama awak. Aras. Ni Arash. Okay dah. Okay. So saya extend sampai 19 lah. So awak ada masa untuk buat lagi. Okay. So this one adalah dia punya, apa nama dia? Line integral for this one. So the flux integral, okay, the flux integral of the sphere, dia akan jadi integration over the bounded region S f dot n ds. It will be integration over the bounded region for upper part f dot n ds plus the lower part. Okay, this is upper and this is dia punya lower of the hemisphere. So sama dengan 2/3 pi A kuasa 3 tambah 2/3 pi A kuasa 3. So you will get 4/3 pi A kuasa 3. So itu adalah dia punya jawapan akhir. So next class kita tengok using Stokes theorem. Dia akan jadi very simple. Stokes theorem dengan divergence theorem is very simple lah compared to surface integral. Okay. So this is all about the surface integral for the vector value function and also for scalar function. Okay. So in the next class kita akan tengok Stokes theorem. Ke nak masuk terus hari ni Stokes theorem? Ada masa lagi ni 30 minit. Gauss theorem. That is the divergence theorem. Dekat hari Isnin nanti tak adalah Penang pula kepala kau. Bagi hadam ni dulu. Okay. Peace, okay peace. Hafiz Fikri. Izzati Nurina An-Nur. Apa nama? Adam Rifa. Dulu ada penyanyi hip hop nama dia Rifa. Tak mana tadi. Okay. Aiza Izwan. Aiman. Akil. Arif Afifi. Nizamuddin, Maiki, lama tak dengar Maiki. Okey ya semua. Rabiatul Adawiyah, Sareh. Ramai pula 45 orang. Betul lah. Lagi satu petang ni. So this is the surface integral. It is a bit complicated because we want to find the flux integral of the sphere. Okay. So later on we will take a look into how you are going to simplify this surface integral by using divergence theorem or also known as Gauss theorem. And then we have another one is Stokes theorem. So macam hari tu Green's theorem give an alternative untuk line integral. So Stokes theorems and divergence theorem give an alternative for the surface integral. Okay. So jadi simple aja nanti integration dia. Very very interesting all those theorem. So beginilah. Ada soalan tak? Kelas. Hui. Senyap je tu.
Ada.
Ni dah ke belum? Surface integral tak silap saya soalan nombor 3 ke soalan nombor 4. Nanti saya bagi apa nama dia? Tips for the final exam. What is covered and what is not covered in the final exam. Dia tak boleh bagi mini love dekat dalam Microsoft Teams ni. Dia boleh bagi love merah je. Okay, tak ada soalan So if there is no question, that's it for today. Ni lah buat siapa nak cipta mini love macam Korea tu. Shock sikit. Tengok-tengok dalam kau poket. Mini love. Bagilah duit. Okay, so that's it for today. If tak ada apa-apa question, I'll see you next Monday. Okay, so assignment saya akan tukar tarikh dekat dalam Ulearn, dekat dalam grup saya dah bagi, tahu extend sampai 19 Januari. So you will have enough time. Okay. 19, 20 okay lah, accepted. So that's it. Thank you class, and cantik ni, banyak love. So have a good weekend. Weekdays. Okay. So I'll see you next week.